As my last name suggests, yes, I'm Korean. Entire screen. There it goes. Slideshows. There it goes. Okay. All right, let's get started. First thing first, I say this every time for my students as well. If there is any discussion, if you need to have any discussions, I'm more than welcome to. Having discussion within your friends, okay? Just make sure that if the discussion gets too long, okay, hopefully you can keep it quiet down, okay? So to respect other fellow students. Okay, so today, what I'm gonna do is we are going to explore what is Python and why are we learning Python, and hopefully I can explain you what is AI. Okay, so you guys heard about AIs. Well, raise your hand if you guys are using ChatGPT by any chance. Anyone using ChatGPT or anything related to ChatGPT? Okay, okay. So more or less, a lot of students, even in my university, a lot of students are starting to use it. We cannot stop it. We as in lecturers, we cannot stop it. Once you get into the job companies, there's no real legal barriers that's stopping you from using it. So hopefully I can also elaborate a little bit on why we're learning Python, why am I talking about AI, and in the end, at the end of the day, all the things that you're gonna learn today, because some students ask, Prof, we have ChatGPT, why are we learning Python? Why are we learning about AI? Hopefully I can answer that question a little bit, okay? So software, right? Anyone know what is the difference between software, the program? Anyone knows the difference here? If I say, can you define software? Can you define programming? Do you know? Okay. So software it's basically a very broad term that includes the apps. I got here using Grab. Okay. The Grab is an application. It's an app. It's a software. If you're a heavy gamers, a lot of games, right? Those are the softwares, right? If you ever rode on a Tesla has an autopilot, and in States, right, they have an autopilot. It's a software that they're using, okay? Your computer, Windows, Mac, all this, these are all softwares, okay? So what is the definition of the software? The software is made of a set of instructions, basically telling the machine what to do, okay? And it is a sequence of a task for the machine to follow to achieve what human wants to do, okay? Another word for this is that the software or these instructions are the rules. Basically, for example, right, if I ask some of you, can you do 4 times 2, right? 4 times 2, 8. As a human, right, we kind of memorized already, what that 4 times 2 is, right? We actually memorized the whole table. So right away we think about 4 times 2, 8, right? But how can we teach that to a program? How can you teach that to a machine, right? So we need to use quote unquote programming. We need to give a set of instruction for the machines to understand. Now I toned everything down to very simple, 4 times 2. But when you're working on a civil engineering problems, the complexity of the problem actually increases quite a bit. Now, do you know how to break down a complex problem into a small bit so that the machine, right, the computers can understand, right? Now, the programming, right, is the interpretation of the task that you have. It's an interpretation. It's a way of communicating with the machine, okay? So let me actually jump to this one, okay? Right away jumping into discussing why do we use software? Why do we use programming, okay? So this is an example of the engineerings, right? In ancient eras, right, when you're building something, what did you do? What did they do, right? They use human force, right? They use the animals to carry heavy loads. Now, as things get better, as the technology is advanced, what happened in the Middle Age? You still use human force, we still use the animals, right? But something new came up, which is the primitive machineries, right? Now, as things get more advanced, right, in the modern era, we still use human force, right? I think, along the way, maybe the Tesla or the humanoids get better. Maybe they will replace the humans, but it's far, far future. But at this time, we're still using human force. We're using vehicles, right? But what we have here is advanced machineries. Now we can make a complex structures like a Marina Bay Sands, right? We have in Singapore. There's so many different beautiful architectures that are actually made using the modern day technologies. Okay, so good. But then, what is actually going on here? Okay, what is happening? Okay, from the ancient era to right now, what's going on? Okay, can you think about that? What is improving? I mean, of course, there is a technological advancement, but what does that technological advancement gives us? Productivity. Okay. It actually increases the productivity. Like, we can do so many things, so much things, compared to the ancient eras, right? Humans now, actually, we can achieve so much more than what we could do, in the ancient era, in the Middle Age, okay? Now, linking this back to the software, like, the question again, like, why do we use software? Why do you need to learn how to make a software, right? So software is a broad term, like applications, all these apps, right? Those are softwares. In order to make that software, in order to make that program, you need to learn how to make a program, right? So you need to actually know how to build a program. Now then, why do you need to learn this? Okay, why do you need to learn how to make a software or use software? Productivity, right? Because software can automate things, okay? It increases the efficiency. Now, I hate to say this, but if there's more things that humans are getting involved, there are a higher chance of making an error. And I hate to say this, but computers don't make mistakes. I mean, if you programmed it correctly, then it's just following the rule sets. Okay, it's not actually making an error. There's no human error, right? I mean, the very basic example here is like when you're working on, I don't know how many can relate during the primary school year, right? When you're going through, has anyone done Kumons? In Singapore, there's a Kumon, right? Right? If there's anyone done that before, right? Kumon is known for their rigorous, solving problems, right? There's so many things you're solving, right? Even when you're working on a very simple addition problem, there's somewhere in the way you make a mistake, right? Because your focus may be not there. Okay, so human errors. Okay. Now, having an automation, right, means that less human intervention. Right? You can actually spend your valuable time for something else, right? So you can achieve more things. So why don't we just, not just saying that, oh, software is so nice, software increases the productivity. Why not we actually use an actual number here then, okay? So in this slide, what I've described here is, let's assume that you have 5 million data instances, okay, 5 million, now composed of a height and weight of Singaporeans. Okay? Now, I give you a task, okay? For everyone in Singapore, you need to calculate their body mass index, okay? Now, let's say it takes 10 seconds for you to compute the BMI per person, okay? Now, how long does it take? 10 seconds multiplied by 5 million data, right? 50 million seconds, okay? That's the equivalent of 57, almost 58 days, non-stop. No sleep, no eating, no restroom, nothing. Non-stop working, 57 days. Now, if you're saying that, oh, hey, I cannot work that long, no one can work that long. So if you have an 8-hour job, 7 days a week, so you don't have a weekend off, okay? You're working from Monday to Sunday, Sunday to Saturday, right? Back to back. How long does it take? 174 days. Okay, that's almost half a year. Now, what if we can actually introduce something better, okay? So for you, it took almost half a year, right? Now assume that a software, okay, can compute 1,000 BMIs per second, okay? So if a computer can solve BMI problem, they can measure the BMIs, 1,000 BMIs per second, that means they can complete the whole thing in 1.3 hours. Pretty quick, right? Now, if we tone it down and say, okay, so I have very old computer, right? Now, this can only compute 100 BMIs per second, 13 hours. I mean, it's still better than us, right? Now, if you ask me, is this real? Like, is it real that a computer can only compute 1,000 BMIs? No. They can compute millions. Okay? So actually, it's much, much, much faster than this. Usually, for 5 million records, I think it will take less than a minute in real life. Okay? So as you can see, so much faster than you. Okay? Now, you don't have to burn half a year to complete this. Now, imagine if one contractor comes to you, hey, can you actually compute this? Can you actually measure the BMIs of the 5 million Singaporeans? And you go like, oh, okay. And they will ask, how long it's going to take you? Maybe in half a year. Okay, then they say, oh, I'm going to give you then, maybe I can give you 100,000. Yeah, okay. And if you know how to program this, you're going to enjoy that 100K, and you can actually finish it like what, in 1 minute, right? So that's the beauty of using the software. That's the beauty of learning the programming. Okay? Now, what do you prefer? Would you take the 100K, work for half a year, or would you take the 100K, work for like what, a minute, and then get the job done? Okay? So whichever you prefer, right? But as I mentioned at the very beginning, right? Now this is not it. There's something more, right? With the advent of ChatGPT, right? With the advent of we call the LLM, the large language model, or the smart AIs, right? Now everyone's getting smarter. Everyone's getting more efficient, right? So we need to catch up, right? We need to know what is out there. We need to know what kind of tools are out there, and you need to learn to use them to survive, okay? If you're not using it, your other fellow's gonna use it, okay? Now, this movie, has anyone watched this movie? Imitation Game? No? You know this Doctor Strange, right? Quite famous movie. I mean, it was aired, I think, not aired, but it was in the movie theater for a long time, quite a long time ago. It's about AI. If you're interested, I mean, the scores are pretty high, okay? It's about actual computer scientist named Alan Turing. So this movie actually talks about like the power of computer. It's not about really the AI, but it's about like power of having a program, power of having an algorithm or computer, right, to solve a very difficult problem. So this was actually based on the World War II, where the UK was trying to decipher the German, the crypto machine. I think it was called Enigma or something. And they were trying to build this computer for the first time in history to actually solve that problem. It's a pretty good movie. So if you have time, go ahead and watch. Okay? Any questions so far? Any burning question that you want to ask me at this moment? Okay. Moving forward. By the way, head warning. Now, I'm still introducing you to this thing. So as we go along, there will be a bit more technically difficult topics, but giving you heads up. Okay. So the next question is that, okay, so we understand why we need to use software. Now I explained like why we need to learn to use software, or why we need to learn how to program, right? Then how? Okay. All good. Software very nice, but how can you do this? Okay. Now, if you want to make a program, you need to learn how to program. Right? So we call it a programming skill. It's called programming skill. Now, if you ask me, then what is programming? Okay, I can actually break this down into three different things. Okay, so if I give you, hey, let's make a program that can do 2 times 3. Okay, the first thing is that there is a coding aspect. Okay, so coding aspect is simply writing an instruction. Okay, it's an instruction that we're telling the machine, hey, you need to do this. Okay, once you compute, you need to save it, right? So those are the coding part, is writing and telling the machine what to do. There's next aspect is the programming. So programming is a construction of set of sequences. Okay, here I use the term like algorithms, right? Basically, algorithm is a complex sequence of instructions. Okay, so you have an instruction, you follow this. So if you make, when you're, I think hopefully everyone here made a Lego before. Okay, so when you make a Lego, do you go like back and forth, back and forth? No, you just follow the sequence, right? So there is a sequence of instruction, like that put this block in block there, another block there, right? Those are coding. Those are the instructions, right? Now a sequence of instruction, right, is different. Now to make that Lego, there may be different sequence of making it, right? But that rule book telling you what to do has a specific sequence listed down for you, right? So that's the programming. It's a sequence of instructions, okay? Now the third part is a software engineering. Now we're not, in this course, we're not getting there, okay? In this course, you will be going through the coding part. You might go into the programming part here and there, but software engineering is more for the computer scientists, the programmers. What it is basically they're drawing the blueprints, right? So in the civil engineering, right, or construction, right, there are the workers, right? And there are the managers who manage the worker, and there are people who actually designs the constructions, the buildings. Software engineering is more for the designing of the buildings, okay? The journey that you can expect is a step-by-step procedure. It's not like you're gonna go to the programming and then like wander off and then go back to coding. No, it's a coding first and then programming. So basically, you need to learn how to make a simple IKEA home like this, okay? And then once you get used to it, you make more complex problem, okay? And then if you're good at it, you move on, right? So don't get overwhelmed, because I understand all of you here are not computer scientists, okay? So throughout this course, throughout the 7-week journey of learning about Python, right? Don't get overwhelmed. Like try easy thing first, okay? And build your skill set from the very scratch by doing practice. Programming is like a language. Like, has anyone here tried to learn Korean before? Anyone? anyone tried to learn any other languages other than Chinese, Malay, or your mother tongue? When you try to learn new language, okay? Because I was a big anime fan, Japanese anime fan. I tried to learn Japanese when I was in university years. It took me a long time. I'm not saying I'm fluent, but it actually takes practice, it takes exposure, right? So what I'm saying is that programming, same thing, okay? So do practices, okay? So pop quiz. Quick question. Do you remember what was coding? What did I mention about coding? What is it about? It's about what? Giving machine what? Instruction, that's right. Okay? It's about instruction, okay? Writing a simple instruction, okay? Another analogy that I put here is making a brick. So when you're building a house, when you're building a great campus like SIT Pongo, right? You make the bricks first, right? You have the cement first, okay? So you start from there, okay? Then what was a programming? Coding was instructions. Programming is what? Sequence. There you go. Set of instructions. Okay? So here I put more technical terms like constructing an algorithm using various instructions. You can think of it as a sequence of instructions, right? You can think of the Lego blocks, right? When you make a Lego, right, there is a set of instructions for you to follow. Now, again, there can be many different ways, right? For the programming, there are many different languages. Like when I say language, the human language, there's Chinese, English, Malay, right? Korean, Japanese, so many different things, right? Now, same thing for computer programmings, okay? There are many options. Like if you actually go into the list of programming languages in Wikipedia, if you actually search for that in Google, you will see a ton, okay? Among all these languages, we are going to cover the Python. Okay. This one, I think, for the time being, we may. Okay, let's try. Let's try this. Okay. So this one is basically a coding example. So I've told you that coding is an instruction, right? Writing an instruction. Programming is making a sequence of instructions, right? Then let's work on this example. So here, the example here that I have here is that I want to create a list, okay, of values. List of values meaning like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 7, 11, 13, like list of values, okay? Like what I want to do with this programming is that I want to save this. I want to use this, okay? So what can we do? Begin the program, okay? Create an empty list called values, right? These are the programming steps, okay? So basically, if I want to have a sequence of list of values that I want to use, I want to store, then I need to make, okay, an empty list, empty bucket, okay? And I call that a variable, okay? Basically, you can imagine I have a set of buckets. I name them variables, values here, okay? That's the first. Next is I want to, okay, so now I have the buckets ready, okay? Now each bucket will have a value stored in it, okay? So what they're saying that I want to populate, I want to dump, okay, a numerical values to these buckets. Now, how many? From what to what? From 0 to 100 in this case. So what is the step 2 programming that thing says? For a specific number from 0 to 100, right? So that means from 0 to 100, I'm going to grab all the numbers from 0, 1, 2, 3, 4, 5, 6, 7, 9, all the way to 100, okay? I'm going to add that number to, quote unquote, the values. That was a name tag given to the buckets, okay? Last, what I want to do is that from that list, from 0 to 100, I want to grab number 55, okay? So from the list, okay, I want to find 55. Now, tell me, how would you find that 55? What could be a feasible way? Maybe you can start from 0 and walk all the way down to where the 55 is and grab it. That could be one way, okay? Or there could be many different intelligent ways of doing things, okay? Now that's where the algorithm comes in. Like what are the ways to find that 55, okay? Now, whether you know how to grab that value, okay? Now, let's say if you don't know the existence of different ways to find this number 55, right? If you don't know, maybe you can actually approach it very naively, starting from 0, you walk all the way down to 55, you grab you find the bucket 55, you grab it. You can do that, but imagine that now the number is not from 0 to 100. Imagine it's 0 to 1 billion. You need to walk so long, right? If I ask, okay, from 0 to 1 billion, go find, let's say 5,700,000. You have to walk all the way, right, to find that, right? So as the data scale gets larger and larger, you need more intelligent way to solve this. That's why you need to learn the existence of these techniques, okay? Now, these techniques are not Python techniques. These techniques are a more intermediate level or beginner to the intermediate level searching techniques, okay? So you might wonder, Prof, didn't you just say this is a beginner's class? Why are you talking about like the intermediate or maybe advanced level techniques, right? The reason why I'm talking about this is because now with the ChatGPT, you can actually search, right? So if I actually gave you this problem set, for example, given the array, okay, find the value 55. Right? If you can actually articulate this nicely and you ask ChatGPT, they will give you a lot of solution. The ChatGPT will actually give you, you can actually start from the 0, you can all the way walk to 55, you can grab it. There's different approaches like something called binary search. Okay, there's a quick search. There's different algorithms to go about this. I'm not saying you need to know what they are, but you need to have an information to determine that when ChatGPT tells you, hey, maybe this is a good approach, right? Like if you just blindly buys into that, okay, and if your boss comes to you and say, oh, hey, why did you make that decision? Oh, because ChatGPT says so. Okay, why the boss hires you, right, instead of ChatGPT? Okay, so basically you need to have that information in your mind to actually validate your decisions. Okay, so at least you need to know the existence, okay, of these techniques. Okay, moving on. This one is a history lesson. Now, a few slides that I have is a history lesson, but I'm going to keep it short. Okay. So why am I giving you a history lesson? It's because now this course is about Python, and you might wonder, like, there's so many different things, but why are we learning Python? Okay. Now, the history starts from the very first programming language in 1883. Okay. And as the technology advanced, we went through the autocode, the Fortran, all this, the Lisp. Okay. In the 60s, there was something called BASIC. Now, in 70s, there were very famous code C, very famous, still used. A lot of the spaceships still use this because it's very efficient. MATLAB is one of the simulation experiment mathematic programming came up. MATLAB also, I used it during my PhD. C++ came in. Okay, it's an extension of the C language. Now you see that in 1991, Python was first introduced. It was developed by the developer named Guido van Rossum. Why was it so famous? It wasn't that famous back then, but it got its popularity over the decades for its simplicity, right? It was very easy for the beginners to learn because it was very easy to read and comprehend. Okay. Java was up, 1995. The C#, all these languages were introduced. They come and go and so on. So this one, hopefully, it's a very short movie to watch. So from the 70s, you can see the Fortran was very nicely used. I'm going to fast forward a little bit to about here. Now you'll see the Python popping up pretty soon. Not yet. Not yet? Come on. Wow, still the C. You can see that the Python was invented, but it wasn't actually gaining a lot of popularity. Oh, there it goes. Put the other one. So you can actually see the Python has climbed up to the rank 3rd. The Java and JavaScript are very famous because of all the web services that you see, that you're using. Okay, so wow. So now, 2022, still 3 years back, you can actually see the Python is right now #1 ranked. It's the most famous programming language that we can find throughout the whole world. Okay. Now, if you see that Python was initially introduced in 1991, but it gained popularity and was ranked into this list around 2001. Okay. So it took about a decade to actually gain popularity and get used pretty extensively. Okay? Now, if you ask me now again, like why are we learning Python? Because it's very famous. Now, if you learn it, then there is a very high chance that you will use this in your workplace. Okay? And another reason is very simple to use. Okay? Now, Python is famous for a reason. Okay? There is a reason for it. Now, many different companies use this. Google use Python extensively. Okay? If you guys ever used Dropbox before, Dropbox is purely made out of Python codes. Okay? There are many pros, many benefits of actually learning Python. One is a beginner-friendly, as I mentioned. It's very human language-like. I'm going to show you later a slide showing you how difficult it is to actually learn C language instead of the Python. Okay? So Python is very easy to learn. Now, Python has very large community, meaning if you actually go into Google, if you want to, you can actually go into the Google and search for Stack Overflow. This is before the advent of ChatGPT. The Stack Overflow was one of the largest community, online community out there to help you guys out. So if you had any questions, you could have asked. You can actually post a thread on a Stack Overflow and ask questions. Python is flexible and extensible. Okay. And it is there's an extensive library. Now this one extensive library part. This one is pretty important because now what I mean by the libraries is that Python, as I mentioned, has a very large community. Okay. So what happened was many other developers pre-built some functionalities for you already. Right? So when you want to do something, of course, you can actually do it from the very scratch, or you can actually try to search online and see whether there is anyone else made that out for you, and you can actually use it right away. We call it the open libraries. Okay? It's a library of pre-built functions. Okay? Now, the last reason, which is one of the most critical reason, is that the AIs, many AI codes, the programmings, are usually done in Python. Okay? But then, of course, when there is good thing, there's also bad things. But usually, the cons here not really impact you, but it's more for the computer scientists. This actually matters a lot. One is it's slow. Okay. Now, because the Python is very much like a human language, okay, it's easy to read. That means it's a bit slower because it's actually far from the machine language. The machine language, has anyone watched the Matrix, movie Matrix? Okay. If anyone of you are interested in those sci-fi movies, right, you might have seen those screens with 0, 1, 0, 1s, right? The 0, 1s floating everywhere. Like those binaries, 0 and 1, those are the languages that the hardware, the computers actually speak. Okay? Now, if I just tell you 0, 1, 1, 1, 1, 0, 1, what does that mean? Okay. So the machine may understand. Humans, right, it's a bit difficult to understand unless you know the binary math, right? Now, if I were to tell you to program everything using the binary language, if you ask me, can I do it? Maybe if I study enough, okay? But Python is more on the human language like. It's like for every item that you see from this bucket, grab that value, add it into another bucket, right? So this is a Python language-like description. So it's it's easier for humans to understand. Okay? That means on the other side, it's slower. Okay? Other issue is that there's slight security issues, but for us, okay, hopefully it's not a big deal. Okay. Third one, it is actually difficult, a bit more difficult to set up the initial environment. Now, this one is more or less handled these days because there exists the Google Colab. I think they're using Colab, right? Jupyter Notebook. Okay. So you guys will use something called Jupyter Notebook. So the initial environment is much easier to set up now. Before that, wow, it was, a while ago, it was quite a challenge. It requires more computational resource, meaning that it requires better laptop. Okay, but modern laptops, usually they can all handle the Python. It's no worries. Does not support multi-threading means there is a you cannot use multiple computers at the same time, but it doesn't really apply in this case. The compatible issues as well. Because there are so many libraries, open libraries, as I mentioned, there are many functionalities, many program codes that other developers wrote, and you can actually grab them and use it in your code environment. Now, because you grab something from some developers, you grab something else from other developers, and when you're using it together, there may be a crash. Has anyone played Elder Scroll, the PC? Elden Ring. If you're into those games, has anyone mod before? No one knows? Wow. Okay. Okay. So basically, it's a game. It's a game. Basically, you can mod it. Mod meaning that you can change the graphics. You can actually make it difficult, right? Because there are many different modifications that other programmers did. If you actually grab all of them and start making the game really fancy, now once in a while the game actually crashes because you borrowed different guys' code, right? Sometimes it happens with the Python if you actually grab codes from unknown developers. Okay? Okay. Next one. So this is an example showing you the difference between the Python on the left side, right? On the left side, and the C. Now, what this line of code is doing is it's telling the machines to print. Now here, the print for the machine is show the humans. Okay? So print hello world, show hello world, that phrase on a computer screen. That's what that means. Okay? Now on the left side, the Python is what? Print hello world, that's it. Okay? But C, what does it say? EINT main, parenthesis open close, the curly bracket, print F, hello world, /n, return 0. There is a meaning to that, okay? There's a meaning, all the meanings to that. But you see how different they are, right? Now, the Python, again, is the language that we're going to learn. It's much, much easier to comprehend, much simple to write, okay? Any questions? Now, because the slide from here on will be a bit more mathematic. Slightly more mathematic. Any questions regarding AI, regarding programming, coding? Okay. Okay, let's do it this way, because I'm gonna move on, but I'm gonna move on without actually taking a break. But I think we may not run to the whole 2 hours, but I may cut it a bit short because without taking the. You guys want to take a break now, or move forward, push forward, end early? Okay, okay, okay. So I talked about the Python. I talked about the coding. I talked about the programming. Let me refresh your memory. Coding was instruction, right? Writing an instruction. Programming was set of sequence of instructions, right? I talked about the Python, right? Hopefully everyone knows now why we need to learn Python, okay? Hopefully no one comes to us arguing, Prof, let's do C, okay? Hope not. It's gonna take a long time, okay? So Python. Now you might wonder because, where are we going to use Python? Like, you remember that example that I mentioned about the BMI computations, right? It takes much shorter time for the machines to do the computations for you. Now, as civil engineers, right, when you go outside, do the fields, the surveys, you get a lot of data, right? And depending on what kind of equation that you're going to use, maybe to compute something, maybe it takes you a minute, maybe or 5, okay? Now, you want to actually make things more productive, so you build something, okay? Now, surveying and computing something is one part of the problem. Some other problem maybe has to do with estimation, like predictions, right? So there is AI technique. Now I'm telling you these AI techniques, right? Because it's not about making a program and measure and calculate something. The beauty of the AI is that they do, we call it classification, whether you're a cat, whether you're a dog, whether you're human. In civil engineering, whether it will collapse, whether it's not gonna collapse, right? Prof. Kim, his specialty is slope stability, right? Whether the slope will fall or not, whether it's stable or not, predictions, right? So all these predictions can be done mathematically or through the AI, okay? Now, one of the technique is called linear regression. So you might wonder, wow, linear regression, what is it? Okay? Basically, you can, let me actually tone down the example here. Let's say I ask every one of you, how long have you studied for the final exam? How long have you studied for the final exam? You haven't done the final exam yet, but maybe toward the end of this trimester, I ask you, how long have you studied for the final exam? And you say, oh, I studied 10 hours. Okay? So at the end, I ask, okay, so you studied 10 hours. What's your score? Oh, I got 82. Okay. And I ask another student, how long have you studied? 20 hours. And what is your score? 90. Okay. I ask one other student, how long have you studied? 200 hours. Right? What's your score? Right? 100. Okay. So what am I surveying here? I'm surveying how long have you studied? Okay. And then I'm asking, so what was the outcome of that? What kind of scores did you get? Right? Here, the x-axis, the horizontal plane, maybe the hours that they studied. Okay? The y, maybe, is the exam scores. Now, what I can build is that, after doing all this survey, I can make that linear relationship. I can actually draw that line. Okay? The blue dots are the how long have you studied, and then what your exam scores were. Okay? And I can make that red line. Now, the beauty of this is that after actually I survey all this and make that linear, the red line, now next semester, I can actually tell your junior student that, oh, your senior students, actually they studied this much, okay? I did this study, okay? I did this linear regression study, and it seems like if you want to get at least 80, okay, you need to study this much. Now, what is this? This is an estimation, okay? If I actually tell your junior student coming in and they say, oh, your senior students, you guys studied 20 hours and then they, got 80 marks, okay? I tell them if the student studied 20 hours, he or she will get 80 marks? No, it's an estimation, right? It's a prediction, okay? So that is kind of, is one of the use case for that regression part. Now, how can we actually make this? How the AI, how Python can make use of this? Now, we need to understand a few things, okay? Now, as I mentioned, that prediction, the red line, right, is actually drawn to make an estimation, prediction. Now, given that 3 dots, it's a bit difficult to see, but these 3 dots, right? Now, my job, or AI's job, okay, is to draw the best fitting line. Okay, the best fitting line. So if I actually show you these 3 lines, which one is the best? Yellow, red, black. Which color line best represents? It's a bit difficult to see the 3 lines, 3 dots. Anyone guess? Yellow, black, red, black, right? Because it's right on top of them. Okay? But if I ask you, okay, so black one is good. It's the best. But how bad is the yellow and how bad is the red? Okay? How bad is it? Right? So how do we measure that? Also, again, I'm not going to go into this mathematical details, but there is a way to actually compute that. Okay? I'm not going to go into this mathematical, okay? There's a way to compute that, right? And then the AI will use that measurement technique to determine, hey, if you draw the line like that, oh, it's quite bad. Maybe it's too, bad in terms of a 2. 2 is maybe the score, okay? And if there is, let's say the black line here, perfect fit, so 0. Okay, 0 means here the lower the value, better it is. 0 is the best. Okay, that means there's no gap, 0 gap between the data and then the line that you drew. Right? Maybe red is 2. The gap is 2. Yellow gap 1. Which one is better now? Yellow one. Okay, because the gap is smaller. Okay. Now under this linear regression, okay, those gaps are measured, okay, by the AI, by the program. Okay. So what the AI do, okay, what the AI do is that AI will try many different lines. Many different lines. Okay? Maybe they try the line that is very flat. Maybe they will try the line that is very steep. Okay? And they will see, okay, so as I change this line this way, that way, right, the gap is getting bigger, getting smaller, right? So what the AI wants to do is find the line that has a smallest gap. Smallest gap. Okay? And then once the AI finds that smallest gap, perfect. Okay? It will actually have this kind of line drawn. Okay? You can imagine that we may draw a line something like this. Okay? The green one as well. Maybe the AI, the program, the AI will draw that green line first. Okay? And then measure that gap score. Oh, gap so large, right? That AI will draw another line, maybe before drawing the red one, maybe draw a line like this. And it goes like, oh, okay, still big. Okay? And maybe make a fine change and maybe draw like this. And slowly approach that where the red line is. Okay? So that's the linear regression. Okay? The technique, the takeaway here, okay, is that you can remember there's a technique called linear regression, which is used for estimation of the values. Okay? Of course, if you're the one who's interested in all this mathematics, of course, you can actually take a look into that as well. Okay? So in civil engineers, in terms of a civil engineering, where can we use this? We can actually use this for example, like estimating the strength of the concrete. I had a project on this quite a while back, right? Basically, you can measure the quality of the raw materials. You can measure the water to cement ratio, coarse fine aggregate ratio. You can actually measure all this, okay, and then predict the strength of the concrete that I'm gonna have. So these are the predictions. Okay. Also, you can also try to do something like given the soil structure, soil characteristics, right? And as the rain falls, right, you can estimate, the safety of a certain slope, right? You can actually do that using linear regression. Okay. So technically, what is it? Is that we're looking for the relationship between the input, the hours that you studied, okay, or in this case, the water to cement ratio, the quality of the raw materials, right? Those are the inputs, the data that you have, right? And you're trying to learn that relationship to the output, the strength, okay, the exam scores. Okay. Any questions at this point? Okay. Okay. Here is a snapshot of using the linear regression on Python. Okay. Now you are going to learn how to use Python. So right now, this screen will look very foreign. Okay. But along the way, you will understand. But here is my first try. Okay. To actually decode this screen for you, okay? So here it is. Let me get my pen, the red one, okay? So let's take a look at the first line, okay? It says import numpy as np, okay? Now, remember that open libraries that I talked about? Like many different developers, they actually create a pre-built functions for you. That numpy is the open library. So you're going to import, meaning you're going to use the numpy, okay? And also here, from sklearn linear model, import the linear regression. Now here, the sklearn, the linear model, the linear regression, these are all open libraries, okay? So there's two different open libraries that I'm going to use in this code, okay? The next line is the, oh, it's not actually allowing me to do that, okay? The next line is the xmp.array. It's a bit difficult to see, but you can see the third line. Remember that the bucket that I mentioned? Right? From the 0 to 100, you actually create the bucket, right? np array. Now, np is an abbreviation for the numpy, okay? From that numpy, I am going to, using their pre-built function, I am going to build an array. Array is the sequence of these buckets, okay? Inside, I'm dumping the values. You can see the square bracket 1, 1, 1, 2, 2, 2, 2, 3. Basically, I'm dumping these values, okay? Now, next one, what I'm doing is that I am I call the technical term I use here is initialize. That means I make the variable. I make the bucket, okay? Now, that list of buckets that I made with the 1, 1, 1, 2, 2, 2, and 2, 3 in, I call this bucket group X, okay? The next line, the fourth line, now fourth 1, 2, 3, 4, 5, fifth line, y equaled mp dot parentheses x mp array, that thing. That is an equation. Basically, is a dot here is a dot product. It's basically meaning that it's doing some multiplications, okay, using some information there. Okay, so we have x and we have y. Now in Python, in machine learning, in AI, X usually means the input data. For example, if I ask you how long have you studied, right? 20 hours, 10 hours, 100 hours. Those are the X. Your exam scores, the output of that, right? Output of studying that much, usually we call it Y, okay? X and Y. So Y is some kind of value that is from the X, okay? So after saying that, the next line, the reg equal linear regression dot fit xy, what that means, right? Remember that the 3 dots that we had and then drawing the line, right? The AI will automatically do that for you. And that is done through that line, regression, the reg equal linear regression dot fit xy. That dot fit is a command, it's an instruction that you're giving to the machine that I want to draw that line. Okay, without saying I want to draw that line, they will not gonna draw the line for you. So you have to be very explicit. Okay, so they draw that line for you. So they at this point meaning at that point, they already drew that line. So you already have that line drawn. Okay, and next is what reg score. Okay, basically it's asking, okay, how good is it? Okay, how good is the line that just been drawn? Okay, you can also measure the performance, okay, using the code. The other lines, the reg coefficient, reg intercept, basically this one is a characteristic of that line that the AI, the linear regression code, the machine actually built that for you. Okay, and at the very end, we have the predict. Predict meaning that, okay, now just like the exam, the number of hours that you studied with the exam scores, right? I actually do that, right? Survey that first, and then your junior student, I have a new junior students coming in, then I say, oh, hey, from my past experience, your senior students, students who studied 20 hours get 80 marks, right? That's a prediction, right? So that MP array 35, right? you can consider that as, oh, that's a new student. That's a new information coming in. Now I am making a prediction based on the line drawn, the information that I learned from previously. Okay? I understand maybe for some it makes sense. Maybe for the others it may not. So along the way, okay? Basically throughout the course, hopefully this will actually come to you naturally. Because you need practice. You need to actually put hours to actually practice and understand this code, not just a Python, but this AI aspect as well. Okay? Next slide. Okay, so now what I'm talking about is I'm talking about much more complex stuff. I'm not saying that we are going to learn how to use this. Now, has anyone heard the keyword deep learning before? Raise your hand if you heard about deep learning. Okay, some of you, okay? Now, this is one of the deep learning architecture. Now, architecture meaning is the, how should I explain this? How can I explain this easily? Basically, the architecture means it's a network. Basically, the deep learning architectures are designed to mimic human brains. Okay? You might ask, oh, Prof, how machine mimic human brain, right? What we have is that we have neurons in our brain. Okay? There is something called neural network in our brain. So a lot of neurons. So when I see you guys' face, okay, doing some it's a physics and biology lesson now. Okay, when I see you, the light reflects to you, and then the light reflected from you comes into my eyes. My eyes generates the electrical signal. The electrical signal, right, goes to my brain, okay, through the neurons. Okay, through the neurons. Okay, and in my brain there's a network of neurons, and then that electrical signal traveling along my neurons, okay, will inform my brain, oh, okay, I'm seeing this student, I'm seeing that student. That student is watching something, I think, right? Or someone is actually focusing. That information comes to my mind, right? So that architecture, that connection of the neuron, they're trying to mimic it like this, okay? So that complex deep learning architecture is already built in Python, okay? So now again, if you know how to use Python, if you know how to make use of, not understand how this thing works, but if you understand how to make use of them, okay, you can actually solve a lot of complex problems that you can find in civil engineering domains, okay? And for those of you who are wondering, okay, in Python, what do you need to learn? What are the keywords that you need to know to actually study of the use of the AIs? TensorFlow. You see the NumPy right there? NumPy. Okay? Actually, throughout this course, you're going to learn about NumPy. NumPy is basically doing the numbers. It's called NumPy because it's number Python. It's designed for the numbers, dealing with the mathematics. Okay? Below the TensorFlow, you see the pandas. It's not the panda bears, okay? The pandas is, you're gonna learn it, I think toward the end of the 7 weeks. It's a data frame. We call it data frame. You can imagine it as an Excel spreadsheet, okay? So basically, we're going to have that Excel spreadsheet inside the Python, okay? Now, scikit-learn, okay, is where I actually use that linear regression, okay? I use pre-built linear regression algorithm, the program, in the scikit-learn. TensorFlow, PyTorch, Keras, those are very famous deep learning libraries. Okay? So these are some keywords that you may be interested, if you are interested, to go find it on Google. You can also ask ChatGPT, like, what are those? Okay? Now, this slide is actually, this is a project that I had with Prof. Kim a while back. Basically, this is a bit more complex example of how to apply Python, how to use the AI to estimate something called effective cohesions. Okay? Now, effective coagents in civil engineering, we call it the C prime. Okay. So let me briefly go over this project, and maybe I can describe how the AI is used in this project. So the background is that slope failure, right? So when you have a slope of a soil, often they're triggered by the rainfall. Okay. So when you heard about in this area, this slope, the land actually slided down. In Korea, because Korea is more mountainous, every summer when there's a heavy rain, there's a lot of slope failures. In Singapore, it happens sometime as well, right? So we found that this happens when there's a rainfall. Okay, and we found that the effective coagent, the C prime, is one of the key soil strength parameter. Okay, that determines the slope stability, right? So, and then based on that, according to the lab testing, okay, doing a lab testing to estimate the C prime was time-consuming and expensive, right? Basically, if I want to, for example, let's say I have a slope in Jurong area, right? If I want to actually grab the C prime information, right, I actually need to do the lab testing. Before we actually had to do the lab testing to figure out how stable, what the C prime value is. But then, as I mentioned, it was very time-consuming, very expensive. So our goal was to develop, okay, an AI method to estimate the C prime, okay, from the basic soil properties, not those fancy stuff, but from that basic information, we wanted to estimate the C prime, okay. And to do this, we actually use something called the artificial neural network. It's one of how should I call it? You can actually imagine this as one of the deep learning architectures. So right before the advent of the deep learning, there was an ANN. So we actually use that technology. Okay. So for this, we collected soil data from 37 slopes, and that 37 slopes and over 23,000 boreholes in Singapore. You can see from the map. Let me enlarge it a little bit more. Okay. So you can see that we actually collected from many different regions in Singapore. Okay. And what we did was that the AI, the machine learning, in here we call it the ANN, artificial neural network, ANN. We used the AI model with the soil properties, okay, the simple soil index properties. And based on that, we trained the model with the AI to predict the C prime. Now, just like the exam thing, right? I survey, how long have you studied? How long have you studied? And what was your exam score, right? Just like that. You can actually, there is a very strong correlationship here, right? Basically, we surveyed the soil index properties, and we actually have had the matching C prime, right? Basically, we trained the model to make that estimation, okay? And results were pretty good, okay? The ANN, the AI that we had, was able to predict the C prime with less than 5% error, okay? And this actually shed a light to slope stability assessment. We actually basically propose this method so that we don't have to do the lab testing and have the expensive test results. Now, like this kind of application, having this specific geotechnical problem and solving this using programming, okay, and moving further, applying a specific AI technique to solve this kind of stuff is only done possible because, of course, there must be geotechnical engineers' experts knowledge, and there must be understanding of the programming, the understanding of different AI methods that is out there. You must know how to use them. Now, going all the way back to where I came from, right? At the beginning of this lecture, I mentioned that why are we learning this, right? Why are you learning Python? Why do we need to learn how to program? Why do we need to learn how to use AI, right? And of course, one of them was a productivity, right? And I also mentioned that the reason why you're learning this, okay, throughout the at the end of the day, end of this course, right? The takeaway is that these things exist, Now, I always tell my students, because my students are computer scientists, IT guys, right? They always say, hey, prof, we have ChatGPT. What's the point, right? I just ask ChatGPT, do this for me, right? And I always tell them, so basically, you need to have a fundamental knowledge in your head. You need to have that keyword and knowledge, not in the ChatGPT, but in your brain, to tell whether what ChatGPT is saying, what the AI is saying is correct or not. You cannot just blindly accept, okay? You can actually search for the, I think the keyword is phantomizing. Phantomizing, or I think the other word was ghosting or phantomizing, is that the ChatGPT, while it does not know the precise answer, it tells you the answer so nicely. I'm not sure how many of you read the story, The Three Kingdoms, right? So there was a case where I actually asked specific details of the Three Kingdom character, and it was clear that ChatGPT did not know, but ChatGPT made up a very nice story, okay? The ChatGPT was not admitting that he or she it does not know of this person, okay? But it made up whole story, and I was like, wow, that story sounds very good. But then, I know that character, and then it was for sure that it was not valid. I think that is called phantomizing or ghosting, okay? So what happens? So with problem like this, you ask ChatGPT, hey, tell me how to solve it. It tells you all this information. What if it's wrong? Okay? So you must be the decision maker, not just following what AI is doing. AI tells you to do. Okay? So hopefully throughout this course, you learn how to write code. Okay? Hopefully you will learn how to effectively write programming. Okay? And then I hope at the end of the course, hopefully you will gain insights on how to use some of these AI techniques, or basically build the fundamental skill sets to apply this kind of AI technique in the long run. Okay? All right, so that's everything that I had prepared for today. Now, I am going to see you guys again for the data frame course, okay? So I will see you in 6 weeks' time, okay? Yeah.
Thank you, Prof.
Oh.